Hi everyone, my name is Julián García-Vinuesa. I'm from Chile, and today I'm going to introduce you PANDORA, a peptide-based antimicrobial design optimized by reinforcement optimization. So there is a problem, and it's like a growing threat right now, that it's the antibiotic resistance. This has started because of the overuse of the people, overusing the antibiotics. So this had led to an antimicrobial resistant crisis. And there's like critical cases set by the World Health Organization, like A. baumannii or P. aeruginosa, which usually this type of crises are attacked by traditional drug discovery, but this process tends to be slow, expensive, even toxic for the patients, and with poor specificity with the target that they want to attack. So in the past years, there's been like a new way of drug discovery that is antimicrobial peptides or AMPs.
Online audience doesn't see the presentation.
Thank you. So as I said, there like in the past years, there's been a new way that to discover new drugs, and there is like antimicrobial peptides (MIPs), which has a few benefits with broad activity, high specificity, low resistance, but it has their downsides. In this case, rapid degradation in the patients, and problems with the design, in this case of rational design. So um, we want to leverage this problem by introducing you Pandora. This is a multi-agent platform that consists in using AI for designing new antibiotic peptides. And the way that this works is that combines predictive, generative, and classification models within a multi-agent system that works like a team of virtual scientists to create, evaluate, and optimize new therapeutic candidates. This platform offers an autonomous way to generate the peptides. It reduces the time that the researchers have to invest to discover new drugs, and in the same way reduces costs. And the major benefits is that it's adaptable and scalable in the sense of we can create new models or modify the model's existence to cover new frontiers that we want to research. So it all starts with the prompt that the user gave us. This prompt gives us what models do we have to turn on and turn off in the case of giving the user the peptide that he wants or she wants. So it all starts with the generative models. Here we are investigating a few ways to which are the best to generate these candidates. They're like variational encoders, neural language models, diffusion models, etc. And then the created peptides are first filtered by the classification models. That is, they're used based on the prompt that the user gave. So this in this case, I put like 5 types of classification that can be the first filter. In this case, antibacterial, anti-gram positive, etc. And we are currently developing these classification models here in the first picture in the E. You can see that we use pre-trained protein language models, and we train different ML classic algorithms to start to discover where do we want to continue to pursue the classification, like the best classification. And the other is like the ROC curve or the precision recall curve and the confusion matrix that we are like going in a good way. So then the second filter is the predictive models. So here we had the first filter that was the classification models. Then we moved to the predictive. And here is based on the, again, of the input that the user gave us. And we filter based on the half-life, for example, the ratio that he wants or she wants, or the IC50. Here we are not only trying to search sequence-based models, we are also trying to pursue to integrate geometric deep learning. So here we are like researching which one is the best. And then like the third filter that we had like the classification, then the prediction models, and then we have the in silico validation. So it's pretty straightforward. If has the activity, an example, or the affinity that the model says, we can filter and say, oh, okay, yeah, in silico, this by docking or molecular dynamics says that it's consistent with the predictive models. So here in the case of docking, we use like restrictional docking, no restrictional, etc. The different ways we're exploring, but the main idea is to have this integrated platform. And it all finished with the reinforcement learning module, where we have like this potential, in this case, antibacterial peptide for a wet lab, but we want to have another, maybe modify this sequence, maybe like upgrading the activity, reducing the toxicity examples. And we can use it by insertion, deletion, substitution, or swap in this case, in the protein sequence. So in this part, is the changing module, because we integrate the lab info and we updated this model. So there's like the reinforcement way. So this is an overview of Pandora with the 5 modules. And what I want you to take home is that this works with the input sequence. There is like some models, classification and regression models. There's like the validation of the in silico that the predictive models predict, and the generation of better sequences. And we want to pursue to validate this platform via proof of concept in the lab. So thank you all for listening, and thank you for all the people that make this possible. And if you're interested to make some questions, David Medina Ortiz and me, Julián García-Vinuesa, we have 2 posters. So ask us. Thank you so much.
Thank you. Interesting talk. Do we have questions? No, which is maybe good because we don't have so much time. But you have a poster, so if people are interested,
Yes.
I think they would stop by. You have a question? A quick one, please. Yeah.
Hi, thanks for the talk. I have a question. Why is this multi-agent system? Could it be achieved with like a parameterized workflow as well?
I didn't hear the last part.
Why is this an agentic system? Why does the agent make choices? Why is it not a predefined workflow?
Why the agent makes choices, but it is not a predefined workflow?
No, we want to, there's the models that we don't touch, that is the classification and regression models, but the part of the generative, like the contrastive learning, the reinforcement learning, sorry, is the ones that being updated. So that's the way that the model modifies it to grab it, like gives the user better peptides. I don't know if answered the question.
Partially, yeah. Thanks.
Thank you. Okay, let's thank the speaker.
Thank you.